One important measure of heart function is the cardiac output. The cardiac output refers to the volume of blood that is pushed out of a ventricle into an artery in 1 minute. Although the cardiac output only measures the volume of blood coming from one of the ventricles and going into the artery that it pushes into, the cardiac output from the right side of the heart and the left side of the heart should be the same. Let's imagine what would happen if they weren't the same. Let's say, for example, that the right side of your heart pumped more blood from the right ventricle into the pulmonary circulation than the left side of your heart pushed from the left ventricle into systemic circulation. In this case, you'd end up with a buildup of pressure in pulmonary circulation because you're pushing a lot more blood into pulmonary circulation than comes back out and goes into systemic circulation. That buildup of pressure causes fluid to build up in the lungs, and that causes what we call congestive heart failure. On the other hand, if the left side of your heart had higher cardiac output than the right side, then the left side would be pushing more blood out into circulation than the right side was able to gather from circulation and push up to the lungs. So you'd end up with extra pressure building up in systemic circulation, and that could lead to edema. The cardiac output, which is usually measured in milliliters per minute or sometimes liters per minute, is calculated by a simple formula. To get the cardiac output, you take the heart rate, beats per minute, and multiply it by the stroke volume. The stroke volume is the volume of blood that's pushed out of the ventricle with one contraction. The average resting adult heart rate is about 75 beats per minute. The average resting adult stroke volume is about 30 milliliters per beat. So based on that, what would the average resting cardiac output be for a healthy adult? Go ahead and pause the video and take a minute to figure it out. To get the answer, take the heart rate, 75 beats per minute, multiply that by the stroke volume, 70 milliliters per beat, and when you multiply that out, you get 5,250 milliliters per minute. Or if we switch to liters, that's 5.25 liters per minute. Recall that normal adult blood volume is between 4 and 6 liters. If your cardiac output, the amount of blood you push out of a ventricle every minute, is about 5 liters, then you're essentially circulating your entire volume of blood every minute. Anything that affects the heart rate or the stroke volume is going to affect the cardiac output. So let's take a look at each of those factors independently. Let's start by looking at things that affect the heart rate. The heart is autorhythmic. So the SA node in the heart is what automatically depolarizes in order to cause each heartbeat. The speed with which the SA node initiates the heart rate is regulated by cardiac centers in the brain. These cardiac centers are found in the medulla oblongata in the brainstem, and they receive information from the body and from the brain about the conditions in the body and the level of activity. And then those cardiac centers make a determination of whether we need to speed up the heart rate or slow down the heart rate. They send instructions through sympathetic or parasympathetic neurons back to the heart to either speed up or slow down the heart rate. If the cardiac centers activate sympathetic neurons, those sympathetic neurons go through the cardiac nerve to the heart and they release norepinephrine. Norepinephrine binds to its receptors on the heart and it increases the contraction rate and it increases the contraction strength. So the heart beats faster and each contraction is stronger. The parasympathetic neurons from the cardiac centers go through the vagus nerve to the heart. They release the neurotransmitter acetylcholine. When acetylcholine binds to its receptors on the heart, it causes the heart rate to decrease. Whether the cardiac centers are going to activate sympathetic or parasympathetic neurons depends on the sort of information that's going to the cardiac center. And there are lots of different areas in the body and brain that send information to the cardiac center in order to control the heart rate. One thing that controls the heart rate is your movement. If you're being more physically active and moving around, proprioceptors, those are receptors that detect your body position, proprioceptors that are in your muscles and in your joints detect the fact that you're moving, and they send signals up to the cardiac center to say, we're moving around more. We probably better increase the heart rate so we have more circulation. The cardiac center then activates sympathetic neurons that go to the heart to speed up the heart rate and increase the contraction strength. You've probably noticed that emotions, especially strong emotions like anger or excitement or arousal, have an effect on your heart rate. These emotions are all sort of seated or detected in the limbic system of the brain. That's where we detect or feel emotion. The limbic system sends signals to the cardiac centers, and when you're experiencing these strong emotions like anger or fear or arousal or excitement, it activates sympathetic neurons in the cardiac centers that then are going to increase your heart rate and contraction strength. Another important body condition that affects your heart rate is your blood pressure. Your blood pressure actually helps to regulate your heart rate. Your blood pressure is detected by special receptors called baroreceptors found in your aorta and in your carotid arteries. These are important places to detect blood pressure because it's detecting the pressure of the blood when it first comes out of the heart, gives you an idea of how much pressure you have to carry blood through the body, and it also detects the pressure of the blood going up to the brain because it's pretty important to get adequate blood flow to your brain. When these baroreceptors detect high blood pressure, they send signals up to the cardiac center to say the blood pressure is high. We need to reduce the blood pressure. That activates parasympathetic neurons. The parasympathetic neurons come to the heart and they reduce the heart rate. That's going to push less blood into the arteries and that's going to reduce the pressure in the arteries. On the other hand, if your blood pressure is too low, then the baroreceptors send signals up to the cardiac center that are going to activate sympathetic neurons. The sympathetic neurons are going to increase the rate of contraction and increase the contraction strength, so you push more blood out into the arteries and raise the blood pressure to where it belongs. There are several other things that also affect heart rate. Just a few examples include body temperature. As your body temperature increases, your heart rate increases, and as your body temperature drops, your heart rate drops. Several hormones also affect the heart rate. For example, epinephrine, which is adrenaline, is essentially the same compound as norepinephrine released by the sympathetic neurons. And so it has the same effect as the sympathetic neurons. So epinephrine is going to increase your heart rate and contraction strength. This is released from the adrenal cortex and the little adrenal glands on top of your kidneys in response to some sort of stress. The other hormone that has an effect on your heart rate is thyroxine, the thyroid hormones. Thyroid hormones speed up your heart rate like they speed up metabolism in general. So when you have more thyroid hormone, the heart beats faster. People who have hypothyroidism, that's a low level of thyroid hormone, tend to have lower heart rates. Finally, there are a lot of drugs that affect the heart rate. Things like caffeine, nicotine, cocaine, amphetamines, they all increase the heart rate. And other drugs can slow down the heart rate. Beta blockers is an example of a class of drugs that decrease the heart rate by inhibiting the sympathetic neurons going to the heart.